Yeah, this video is about improper integrals. The first one is the integral from 1 to infinity ln of x dx. As the definition of improper integrals says, we would write it as limit of 1 to a letter like t when t is approaching infinity, ln of x over x dx. In order to solve the integral, we have two options. The first option is when you see the inside of the integral of 1 over x times ln of x, this one is the derivative of the other one. And if you see it in this way, dx, so you would say, okay, I have the derivative next to it, so let's write ln squared over 2. But if you don't see this way, you would say, I would like to use u sub, and I would pick ln of x as u. So taking derivative both sides, we will have 1 over x dx. And the integral will be written as u du because u is ln of x, and instead of 1 over x dx, we have du. So the integral will be u squared over 2, and since u is ln, again, we have ln squared over 2 as the solution. So with both approaches, you would have ln squared over 2 from 1 to t. Let's keep the limit here still. When you plug in t, you get ln squared of t over 2 minus, when you plug in 1, you get ln of 1 over 2 squared. We know that ln of 1 is 0, so this part is 0, and that part, ln squared of t, not b, why this one is b, will be infinity because ln of infinity squared over 2 is infinity and the integral is divergent. Let's do the next one. The next one is the integral from negative infinity to 0. So again, using the definition, it says keep the limit out, and you would have, okay, you would have b approaching negative infinity and the integral from b to 0 x e to negative x dx. We have two functions that are multiplied together. None of them is the derivative of the other one. So we have algebraic here, we have exponential here. Between these two, u for integration by parts will be x, and the rest of it, e to negative x dx, is dv. So this one, when you take derivative, is dv equals dx, and this one, when you take integrals, would be negative e to negative x equals v. So we would have limit b approaching negative infinity, and the integral using integration by parts will be u times v, which is negative x e to negative x from b to 0 minus the integral from b to 0 of v du, which is negative e to negative x dx. So limit is still here. For the first part, when you apply the boundaries, for the top, it will be e to 0, which is 1 times 0, so you have 0. It is defined. Minus whatever you have after plugging in b. So it will be positive because we have, or I can write it this way, b e to negative b. This is for the first part. Minus, when you have the integral, the answer of this one, make these two positive, would be negative e to negative x from b to 0. So you would have limit b to negative infinity. This will be b e to negative b minus, when you plug in 0, you get e to 0 minus, when you plug in b, you get e to negative b. Altogether, we would have limit when b is approaching negative infinity. This one is just 1, so you would have b e to negative b plus e to negative b. This is minus, not plus. Okay, let's say plus 1 minus e to negative b. When b is approaching to negative infinity and b is approaching negative infinity, we would have, for this one, we would have infinity times infinity. And also here infinity. So all together we would have infinity as the answer, and this will be also divergent.